Okay.
So welcome everyone, and thank you so much for your patience. There we go. We had a big learning curve just for the past 15 minutes. Welcome, and if you weren't here last time, my name is Jen Carter. I'm a numeracy coordinator in Vernon School District. And Deanna, do you want to introduce yourself?
I am Deanna Bracich in the Sook School District. And I'm hoping you can at least see us because right now I just see Jen. Jen, are you sharing your video as well?
Hang on, I can't even see while I'm
That's the part of sharing, I know. So Jen is taking a turn this time, right? Because it can be quite, I don't know what the word is. There's Jen.
Okay, so first of all, I would like to acknowledge that I'm actually meeting with you from the Okanagan unceded territory of the Okanagan Silk people, and just want to acknowledge all of the unceded territories out there that we are all learning together from. And this is a bit of a continuation from our session last time, which was on the principles of counting and choral counting. So today we're moving into some subitizing and partitioning and place value, and how we can understand what kids need to know about those big important concepts, and what to look for, and a bit of what to do about what we see when we're making our observations about kids. We're going to hold questions to the end. So we'll hopefully have a tiny bit of time for that. But we'll also have some opportunities here and there for you to enter some things into the chat box as we go along. Anything else, Deanna?
Just like the last one, I think we're going to power through it pretty quickly, but because you'll have a recording of it, you'll be able to go back and watch anything that you might have missed or want to see again. And do expect to have the same older videos, though the sound is pretty good, because they're still just really show exactly what we want to show. So that's about it. Let's go.
Okay, so why are we not? Let's see here, why can't I change that? There we go. We're going to start off with the little counting video, just because counting is very connected to these other concepts that we're going to talk about today. I won't say much more right now until after we watch the video, but just be thinking about, what do you notice about this child and his counting? What understandings does he have in place? And what misconceptions might he have? Last time we were talking a lot about helping kids to connect the idea of counting and number words with quantities, as opposed to just it being an act of labeling things with words. So we'll start the video. I hope you have sound, and we'll go from there.
So normally we would hear him counting these, and we're not hearing him count them one by one. And I'm just going to do a little bit of closed captioning here. And he's counting out all of these animals, and he's going to count 12. And what we're seeing here is that he's able to do the one-to-one correspondence. And then she asks him how many, and he says 12. Then he's given this other set, and she's asking him to count from the crocodile. And he knows there's 6 on the table, but he counts 4, and he actually looks under the table to see where the other ones went. And when you read further in the book, he actually still doesn't understand to go back to the beginning. So Jen, that's interesting that didn't play, but yes, because yes, we did try this. We got this all ready, and your sound was all ready. So thank you to the people who are telling me what to do. So as Jen's presenting, maybe, yeah, I don't know. Let's just go with it.
Okay. Oh my goodness, what a day. Okay, so this slide just kind of shows how counting kind of precedes these other later concepts and how important it actually is. It's for kids to have that connection between the counting act and quantity, helps them later down the road to understand what's happening when they're doing operations. So very, very foundational. The other thing about Daniel in the video is that he just is thinking about that act of counting. He isn't thinking about, okay, when I said 6, it meant 6 altogether on the table. It was just an act. And so when she asked him to start in the middle of the line, and then he counted on, he's like, well, where do I go now? That would be the reason that he looked under the table. So for him, we would need to do lots more kind of counting jobs so that he can understand that we count for a reason. We count to find out how many, and that how many represents a quantity of things. And so that's where we lead into the subitizing. I think most people now know what subitizing is. It was fairly new, I think about 10 years ago. But subitizing is when students can see at a glance a quantity, such as on the dice or dominoes. Often in primary, we use 10 frames. And by the end of grade 1, we expect that kids can subitize to 6. I think babies can subitize up to 3. So it's a really, really fundamental thing that we need to make sure kids have in place in the early years, in the very early years. Subitizing actually does precede counting and underpins it. So because when kids are counting, they should be, if they have an understanding of counting, thinking as they go along 1, 2, 3, in their mind, they're picturing those 3 as that quantity. It's through the use of the counting sequence with subitized amounts 1, 2, and 3 that children begin to realize that we're referring to the same idea, the idea of quantity when we're counting. And seeing 3 is more than 2 and 2 is more than 1 helps children to learn that counting numbers go up by 1 each time. We talked a lot about that last time. So, we often see, working with dice formations or dominoes or 10 frames, like I said, are a big one in primary, but we can have our kids thinking about using subitizing with all different types of materials and things around them, outside, with their fingers, very important. See if there was anything else. I've had kids in grade 2 who I've asked, make 6 on your fingers, and they have to count to get to 6. That's very troublesome, problematic. We want kids to be doing lots of activities and things with their fingers so that they can automatically make those quantities without having to count. Oh, there was one more. Subitizing helps us when we have a bit large, quantities that are a bit larger, because we can think about how many birds are in this photo by thinking in groups. I can see 5 and another group of 2, and so putting those groups together to figure out a larger quantity is something important. And this would be a regular routine that I would do with my students if I was teaching grade 2, grade 3, even some of the higher grades. Actually, kids need practice with this, and it's something that they have to develop. It's not necessarily something that they automatically have.
Yeah, so if we can keep it there, one of the things about this and using it in the higher grades is it's a great number talk to see how they're actually putting their numbers together. This one would require an accurate count because we'd be able to subitize it. And you can have kids, circle it. If we were in a workshop, one face-to-face, we would have you circling it just to compare how we all see the subitizing difference. Some of us can subitize 5 instantly and some of us can't. And that's the same with kids. So this would be for a more accurate count.
Yep.
And the next one.
A slide such as this one just helps kids to practice estimating. So if they can, this is a great routine to do as well with students, and a great, as Deanna was saying, like a sort of a number talk or an estimation talk, because we have to teach kids how to estimate, and we do that by talking about figuring out how many birds approximately are in a section, and then how many sections are there altogether. And that's something that kids, again, won't know on their own. It's something we need to.
Yes, something we need to explicitly teach and model for them constantly, and have other students model. And one of the great sites, it's like Estimation 180, those kind of things where they're given opportunities to see how other students are estimating.
Yeah. So out of First Steps in Math, there's this activity, number scatters. It's basically like a dot formation number talk, like we've just been showing you, but kids can play it as a game where they are flashing a card and asking how many, and their friends have to try to be the first to guess or to subitize and say how many are on the card.
And if you wanted, oops, sorry, Jen.
Oh, I was just going to say that's something that you can have your students doing, and then as the kind of diagnostic, you're going around and just listening to hear which kids can subitize and which need more practice with that.
And to take the competition out of it, because it doesn't have to be a competition. And this is something that you'll see with First Steps. We've kind of moved from this program, is that you can just have them both compare their answers and see if they get the same answer, and then talk about how they go about getting the answers to compare what their procedure, what their process and their thinking was. So that's one thing that I've changed with this, is taking that competition out, and it makes kids not blank out so quickly.
Yeah. Deanna, I was just thinking really quickly, do you want to have the other videos kind of up and ready, because we will need the sound for them, and maybe you could share those?
Well, is the video coming up?
There will be one soon.
Okay, so if you want to just do this slide, and do you want to check your audio settings to make sure that you're able to share them, because it'll be on your side because you're sharing.
Okay.
But yes, I was just going to talk about this. So if you just want to look at it right now yourself, and we would normally have you going into the chat, but I think we can probably just think about it. Just quickly, how many do you see? And then how do you see that many? And that's how we would do it with our students. For those of you in the older grades, if you have kids that are struggling, you need to be doing this kind of thing just to get back to the basics and back to counting and subitizing, because we know that that's what's going to bring forth their ability to add and subtract. So everybody's going to see these differently. Some people will see 7 right away. Some will have to see the 4s and the 3s. But what's important here on a number scatter is that it is unorganized. I like that it has one piece where that 4 is organized, and that's something we see on a die. But you want it to be unorganized, so that forces them to think outside of only organized representations of number. So thinking about what would you ask the student, but this is exactly what you would have on your desk, or go around the room while they're working quietly or silent reading, all those moments in time we have in our classroom. If you're an LST teacher, this is something you can do in a session just to check and see if they're able to determine the quantity by what they're noticing and what they're I was going to say counting, but you don't want them fully counting at this point. You want them subitizing. Are we ready, Jen? You think you're ready?
I think so.
Yay!
Hopefully it'll work. Yeah, so I love this quote by John Vanderwall. His book is just like the key resource, I feel, for math teaching. But so he has said to conceptualize a number as being made up of 2 or more parts is the most important relationship that can be developed about numbers. And so heading now into thinking about composing and decomposing numbers, we want students to realize that it's easier to see how many there are when collections are in special arrangements. And so many kids don't know that, need to be taught to arrange items to see and to count and to keep track. that a collection can be separated into parts and each part can be represented by a number. Thinking part whole can help us see how many there are. A number can also be thought of in more than two parts, and the same number can be thought of in parts in different ways. So those are some things that you could use that, that's a nice slide that you could keep handy with you so that you have those things to watch for, those understandings that we want to make sure kids have in place. And that's actually, if you're reporting to parents, great feedback to give too for things to work on at home.
So we had a question about whether if there's a special website or anything that would work on subitizing and work on partitioning using their subitizing skills. Jen, what's your favorite?
Yeah, I'm going to talk about that actually.
Yay, I didn't know if you had a slide. Okay, can I talk to this slide just really quickly? Yeah. So each of these are almost like a little checklist that you can make sure you're doing in your classroom when you're explicitly teaching or exploring or having them discover subitizing. So having them arrange unorganized collections into an organized, that's a task you want them to be able to do. Being able for them to take something that has a collection and be able to put them in different parts, being able to see that this part is part of a whole is another task you want them to be able to do. And also that it's more than just two parts. So one thing that I find when I talk with teachers, they'll do the whole part frame for kids, but you have to remember that the part could be 3 or 4 or 5. And that's where your number talk will explode, because you will have those kids who are, in that higher range of thinking. They'll be the ones that are pushing the envelope on that one. And then, of course, that last one is a brilliant one, whether or not you're using plasticine on a desk or stickers on a card or a bingo dabber or Q-tip with paint, just taking, okay, let's do 25. Show me all the different ways you can group 25 on a page, and then have kids go around and do a gallery walk and see if they can subitize their friends' numbers. It's all, you know what I mean. But it gets me really excited because it's something that's very exploratory with kids, and you involve them in the learning and the creating of the resources that they can learn from.
Nice. Okay, so this part whole understanding, it actually is the basis for place value, and kids need a lot of many experiences with this reorganizing of quantities into something more arranged, because it helps them, it supports that visualization piece that kids need to do mental math. And it's something that does have to be practiced and developed. I remember I wouldn't say super early in my career, it wasn't that long ago when we had, some of our student support kind of experts saying that that working memory can't be, it's just a fixed ability that kids have or don't have, but we know now that that's not true. Kathy Bruce's work around all the spatial reasoning stuff has shown that this skill can be developed in students, and it is really important. We need kids to be able to rearrange and visualize, 10, for instance, in their minds, and then eventually be just doing that with numbers, but it has to start with the quantity piece first. Okay. This is just a great visual to show that these things that underpin one another and down the road will also support those more complex math concepts. I know when I taught grade 2, I did this number, a colleague and I did this number of the day routine every day in grade 2. And a couple years later, our grade 4 or 5 teachers were saying, oh my goodness, not sure what you're doing down in primary, but we don't need to teach place value anymore. And I have found that teachers that do this number of the day say they don't teach place value. And they don't have to anymore, because that composing and decomposing helps kids understand place value. Okay, so here we go, moment of truth. I think for this one, did we want to do the chat box, or are we going to just save time?
I think we're just going to go and let people think.
Okay. Let's see.
Research is showing that children invent their own, sometimes surprising ways of adding. Noah is adding 5 and 3.
You can use your fingers.
8.
Yeah, show me how you figured it out.
See, 5 takes one more away from 4, so it has to be 8.
Wait a minute, I don't understand.
No, let's see. Now 5, or like 4.
Mm-hmm.
And add one more, and you take one away from this 4.
Oh, so where'd you get the 4s, though?
You see, because you see, I got the 4s from the other way you can make 8.
I see. Like 4 and 4 make 8.
And
So that's how you figured out 5 plus 3?
Yeah.
Wow, that's pretty smart.
So
Okay, so thinking about what Noah needs or doesn't need, well, he doesn't need to think of a collection or breaking up a collection. He's already working with numbers and able to break up a number knowing that that quantity doesn't change. So he can use that compensation strategy of taking from one to give to the other. And that's the mental map that we want to get our kids moving towards.
And I like the way that he doesn't need his fingers to explain, but he's using them to try to, but it's not quite working because he's just doing it in his hand and he knows that he's moving 1 from the 5. So it's that's what you want. That's what you're aiming for. You're aiming for your kids to be able to explain their thinking that way.
Good. Okay. So First Steps in Math actually has a diagnostic task called Animals. It's just basically asking students to think about, well, they talk about a story in First Steps in Math, but Deanna and I agree that just using any local context where you can have kids think about a situation where maybe some animals are on the beach in 2 different groups, or maybe even 3 different groups, and have them write number sentences and in as many possible ways as they can, and think about how to break up that number or break up that quantity. And this is the type of number of the day routine that we're talking about, where kids come in and you have a number up on the board, a random number, and they're just practicing thinking of all the different ways to make that number.
And you can move from concrete to symbolic by, you can start with having the picture and they're using manipulatives to place, and whether or not you have the money to have actual little crabs or anything, but they can actually just place them on there and show all the different ways that if I said, you have 12 crabs and some are in the water and some are on the beach, can you show me the possible number sentences from that set quantity of animals? And they can place it with the manipulatives. Then you can move to them just drawing little, and some will draw forever a little crab. So you teach them just put like a C for crab and getting them to do it that way. And then later on, they're just going to be able to write those number sentences, and you write them on the board and share them, and kids start to see this pattern of how a number can be decomposed in order to do subtraction and addition. So it's a wonderful one, but we both agree we'd rather a picture like this than rabbits escaping from a farm.
Good. Okay, and then another one, this actually was originally out of the Vanderwall resource, but having kids think about, if some of the bats are in the cave and we can only see 3, but there were 6 originally, what is that missing part? Super, super important concept for kids and skill for kids to be able to have and do. I think in the Vanderwall one, you just have counters on the table and then you use a cup and cover some of them up. But getting back to my favorite website for, and I don't have the slide in here because I put it in, but for Subitizing and for this as well is Steve Y. Barney's Splat. So if you haven't discovered Steve Y. Barney yet, amazing free online resources. Don't be afraid to sign up. I only ever get an email from him when he's created something new. But for this, his Splat series is incredible. And it's not just an early years resource. It progresses into quite complex thinking where there's multiple splats that are covered and kids have to use their multiplicative thinking and sense and skills to figure out the amounts that are covered, and then even has a fraction splat series. So amazing resource. I've been sharing this one a lot in classrooms here in Vernon.
And another must-have for anybody in a learning support teacher role, because it's just something that you'll see great results from. And knowing that the splat and the bats in the cave and covering up, and another one that was coming up, is working both their addition and their subtraction at the same time, whether or not they're counting up to find the different partitions, or whether or not they're actually mentally can do the subtraction. So it's nice to be able to work those two operations at the same time.
Yeah, and modeling in the symbolic form for kids, because then you're getting at that the algebra piece as well. When we have the missing part, and what does that equal sign mean? It means balanced and those types of things. So it's a very rich activity.
Yes, and Mark has just mentioned number talk images, another phenomenal one for how many. When you do this, make sure you have like a whiteboard beside them so they can write the actual number sentence when they're figuring it out. That's a great way as well.
Yeah, nice. Another one, this one's in First Steps in Math, Shake It Out. So it's just that idea of them seeing quantities in parts again. And at the bottom one says, just even having two shapes, we can differentiate to help kids, just separate into two groups or more.
Yep. And another one that works well with a gallery walk, with kids walking around. Every kid has one on their desk, and they decide what's in the shape and what's out of the shape. And kids go around and they can write their number sentences, or just come up with a number sentence in their head.
Yeah, good. Oh yeah, just a couple other things we thought about when we were creating this. Just often kids think if some, let's say beans or whatever objects you're using are different sizes, that those are more than the smaller ones. So, help watching for that, and that we can have a quantity of different objects and still be able to count and talk about that as a quantity and partition that quantity. So those are some things just to watch for, making sure kids understand that we can use math and numbers to represent things that aren't the same. Okay, here's the next one. So at the top, it just says, why is place value important? So this video just kind of demonstrates that. Apologize that these are so aged, but they're still so
She
good.
knows her symbols well and writes them down very neatly. She also seems to know the rules of addition. But there's something wrong.
Plus 1 is 7.
So the answer is?
776.
Let's do another one now. 53.
Herbert Ginsberg is gently putting her through her paces.
Plus 4.
What becomes clear is that she doesn't fully understand one of the crucial concepts of arithmetic, that of place value.
Yeah.
4 plus 3 is 7.
Not that her problem is always apparent.
5 plus 0 is 5.
Okay. Why did you write the 4 on this side? Why didn't you write it over there?
That's the way my teacher does it.
Do you know why it's supposed to be on that side?
Why?
I'm asking you.
And the pain of incomprehension is all.
I think the one big point of this video is that kids can get answers correctly without having a place value understanding in place. I mean, that first problem that she did, it was clear that she didn't understand place value, but the second one, it was not clear at all. We have kids that can go memorize procedures very, very well and do those calculations for years without having any understanding of place value. So I would say probably that one of my favorite parts of First Steps in Math, the diagnostics that that were created with this resource is the place value ones, because they really do uncover whether kids have it in place or not. So that's what we're going to move into here next with the dinosaur task. So the way this diagnostic works is you ask, and it can be done as a whole class diagnostic. That's what I've always done with students. Make sure each student has a red pencil crayon and a blue pencil crayon, or just two different colors. You ask students to count the dinosaurs. So they count them, and we all agree as a class that there are 35. They write the number 35 at the bottom, where it says how many dinosaurs are here. Everybody writes it down, and you as the teacher write 35 up on the whiteboard, and then you point to the digit 5. You don't say anything. You don't say the number. You just point to the 5, and you say, with your red pencil, can you please circle how many dinosaurs this digit represents? And then you do the same thing with the 3. And it's really important that we don't say 3. We just say the digit, point to it. And it's very, very clear with this one whether kids have place value in place or not. And we're going to show you some samples of what you will absolutely see probably in several of your students. Do you want to add anything to the instructions with this, Deanna?
One of the great things, well, one thing I want to say is make sure the kids can't see each other's sheets, because they will look, if someone's made an error and they'll look and see someone that's done it correctly, they will change it. So you really want, if you're doing it whole class, make sure they're in super spy mode and they're doing it individually. The great thing about this one is once they're done, you take them in, and again, it's the 2-piler thing. They either got it or they don't. And what you're going to see is the same thing. The other thing is, please don't share with them how they got the answers. And this is with all of the different first steps diagnostics, because you want to be able to do it again. If you have half your class not do well on this, then you're going to want to do it again, and you can do it with dinosaurs, or you can create your own. But do activities that do the same sort of thing when they're separating different parts, but then come back to this diagnostic. So don't share it for sure. And this one, people say, oh, I feel like I'm tricking them. You're not tricking them. If they can't do it, they really don't understand the place value.
Yeah.
Oh, sorry,
sure.
Carry on.
No, I was just showing that point and just saying, yeah, you can do this one. Like Jack, for instance, here, if he doesn't have place value in place, he's going to do the same thing 5 times. It's just so interesting how when kids don't have it in place, this is a typical way that they will respond.
And others will say, well, yeah, but if I ask him later, he'll understand it's a 30. And that's usually because we are asking them the same way. What number is this? And they're like, it's a 30. So I find the big thing for me is that they're not understanding any, like the rest of the dinosaurs. If you're saying there's 35 and you've only circled 8, what about the rest of the dinosaurs? So there's a gap there too that we really want to address. That's going to affect them later when they're doing place value and higher levels.
Yeah, and that gets back to that idea that numbers represent a quantity. Exactly. And if they're not acknowledging the other dinosaurs, then they probably don't have that very early understanding in place. Mm-hmm. Yeah. Okay. Were you going to speak to this one?
Doesn't matter. This is another one that I found that does a similar thing to the dinosaurs. This is Marilyn Burns, and you can find it on her Math Solutions page. She's got phenomenal things on that website. So you're going to watch in the video. There's the script. This lovely little girl, she's going to do exactly what you're going to see kids do when they don't have their number sense for place value. And one thing that we want to say that's a little different, because it's an older video as well, is you'll notice that Marilyn Burns will say the number 1. She'll say, well, what will you do with this number 1? And I think that's confusing, and Jen agrees. So we both agree that it's important not to say what the number is, because it can confuse them, and you want to keep this this assessment as valid as possible.
Okay.
Couldn't you write the number 16? Kind of big. Okay, and you wrote the number 16, and I'm going to tell you with the 16, I see the 6, and I can show the 6 with the cubes. I can show 1, 2, 3, 4, 5, 6, and that's what the 6 means in the 16. Can you use the cubes to show me what the 1 means? Okay, and what about these cubes?
I guess they wouldn't be. I guess they wouldn't go there.
Okay.
Very cute. So she's got a bunch of little videos as well. But again, it's same with the dinosaurs. Like, what about those other cubes? If we're talking about a number, meaning, quantity, what's happening with that? So that's something to watch out for. And again, it's either they get it or they don't. So that's a very quick, valuable tool for you for that beginning place value.
Good. Okay, and I think I get to, uh-oh, why are we not advancing?
I love how we both talk out loud.
What's that?
Both, when we have a panic, we talk out loud. It's like, okay, move into some higher level ones. So end of grade 2, beginning grade 3 and up, but it really depends on your class and depends on your students. For LST, you're going to use these no matter what, no matter how old they are. This is the first one, and it's kind of like a warm up, I think, but they're giving this sheet of paper. And again, they have 2 colors in their hand. They have a red or blue or whatever you want it to be. And you explain to them that these are candies, and in each roll, there are 10 candies. And then the circles are just the individual candies. And I've seen people actually bring lifesavers in and show that to them so they see it concretely. And then you're just going to ask them, well, how many's there? And just like the dinosaur one, that's not the test. They're going to find out that there's 52. We're all going to agree as a class, and we're all going to write 52. And you as a teacher, you're going to write 52 on the board. And then you're going to ask them to pick up their blue pencil crayon, and you're going to point to the 5 or the digit 5 without saying it and say, could you please color in this many? And now on this one, not many kids get it wrong. They're going to color in those 5 tubes, because even if they are getting the right answer for the wrong reason, they're seeing that there's 5 and they're going to color that in. And then you point to the 2 without saying that it's a 2 and ask them to use the other color to color that one. So that's Candies A. That's a great place to start with. And there's a whole script. If you want to use the script exactly the way it is, again, it keeps it valid. So, and I think of that as more of a standard partitioning. So our typical partitioning, place value partition that we use. The next one is called title's wrong, 43 candies actually. And you'll notice now on that sheet, even though we have 43 candies, we only have 3 tubes of 10. And that's done purposely because we are looking for those kids who are going to color in the singles, the digit 3, as those 3 groups of 10 there. So you're going to go through the same thing, but we are all going to agree still that there are 43 candies there. I do sometimes go off and ask them how they figure it out, just make it into a number talk, but essentially they're going to write it down, and you're going to go through the same thing where you're pointing at each digit, having them colored a certain color. Again, you don't want kids to be able to see other kids' answers, because with the color, they'll notice that they're not answering the same, and especially in larger classes. So with this one, you can almost predict what they're going to do. They're going to color in the 3. When they ask to color the 3, they're going to color in the tubes. So if we go to the next slide, you can see some examples of what they look like. So child A did 52 candies, and you can see that they colored it improperly. But when they go over to the 43 candies, they are coloring in those 3, the blue, and then they're coloring in 4 individual candies as the 4 10s. So what we want them to do is the non-standard partitioning, knowing that we can break up that 10 and it's still 10. And that's what you see at the very bottom. That's what you want it to look like. And again, you're going to have those who are going to get it and those who don't. And that's when you want to pay attention. And it's a great way to follow a student's progress if you know they've been working towards a better understanding of this, or to see how your class is as a whole. Can I move on? So it's one of those things that lets you know whether or not you can move to the next steps. So the 52 candies, they can get the right answer for the wrong reason. The 43 candies are going to really show you those kids that are doing just that. A game that you can play for place value that works really well, whether or not it's just that small group that is having difficulty, or if it's the whole class, because it is fun, is that they have their calculators, they keep it on the desk, but they have to have it hidden. So again, super spy mode. And you ask, each partner puts in any 3-digit number. Now this can also be a 4-digit or a 5-digit or a 6-digit, depending on your students. And that's a great way to differentiate as you go around the room. And they're just going to ask, can I have all of your 8s? So if they don't have the digit, you can have nothing. But if they do have that digit in their calculator, then they're going to tell them how much they can have. So if the 8 is in the tens place, they're going to say you can have 80. So partner B is going to subtract 80 and partner A is going to add it. That's going to change partner A's number, and partner B's hopefully will have an elimination and bring it to the 0. And now partner B's turn. And then you can make them go until they reach 1,000. So eventually, because they're adding and subtracting, they'll reach to 1,000. Or you can switch it, and then whoever if their opponent reaches 0, so a negative or a positive thing. You can also use this with decimals, and that's what where I am at for grade 5. It's how we're learning the differentiation between that 2 in the tens place and the 2 in the hundredths place, and what they have to add and subtract on their calculator. Takes practice. So the first time you might pull your hair out. I would definitely do it with them on the board or on your document camera to show them what you're doing, and then just keep it simple first. Keep it at 3-digit, even start with 2-digit if you're in lower grade levels or working with someone that is really struggling with it. But they love this game. It's a very simple concept. Once they get it, they got it, and you can just move the digits up, the amount of digits, or add in that decimal place. Then we have 116 candies. So candies are very popular. What I like about this one is it allows the students to show you both their standard and their non-standard partitioning understanding. So you are telling them that you're going to have the tubes, you're going to have singles, and you're also going to have boxes of 100 candies. And so you're going to ask them, how many different ways can you make up an order for 116 candies? And right now with Amazon and everything, people are placing Amazon orders for 116 candies. This is what you have. What are all the different ways that you can make 116 candies? Now, this can be a diagnostic the way it is, or it actually can be a collaborative task. And that's the way that I've used it before, and especially on the virtual whiteboards. So I meant to take pictures of them doing this year, but this is one I do every year. Just gets them that flexible thinking, and then you'll see how they actually are very challenged to see all the different types of combinations they can make. So that's
I often have teachers asking me, well, how many different ways do they need to show me for me to know whether they have this kind of concept in place? And it really is a professional judgment thing. And I think like what you're saying, Deanna, about doing different activities too, and just watching kids, if you're only just doing one diagnostic, it is sometimes hard to know if kids have some of these things in place. But if you're doing other similar activities in your daily classroom time, you get a sense of, are they partitioning in different ways enough that I feel good about them not moving on, but having a place. Yeah.
And a lot of times it's not about how many answers they have, but the complexity of the answers that they're given. So you can tell right away if someone's being very creative with their answers, if what level of mathematics they're at there, whether or not they're keeping it really simple or not. So not always just how many there are, but what type of answers they're given.
And just thinking about how do I move them on? What are their next steps? Yeah. Okay, sorry. Here.
That's okay.
There we go.
And I love this one. Another one that I do, both standard, non-standard partitioning. You're going to have kids that are going to keep it simple and be very challenged with trying to use non-standard partitioning. And you're going to have kids that that's what they're going to go to first. They're given 3 numbers, and it's great because it's hands-on and kinesthetic. They cut up the pages and they have those. And I don't actually give them the sheet. I will just say, because I don't use this as a diagnostic, I use this again as a collaborative activity. You just put it up on the whiteboard and they have them, and you just say, I need you to make 61 and I need you to make it in many different ways. And with those little cards, they just move them around on their desk and they're talking about it. And there's a lot of aha moments in this activity. So I do strongly encourage you to do it. Especially, again, it's a perfect one for an LST session with someone, just to see where they're at in their thinking and whether or not they've got that flexibility of partitioning and place value. Definitely try that one.
Okay.
Okay, read, write, and say. Now, this is one I actually start the year with. So you are asking them to write a number that you say out loud. So for example, if you say 19, they will write the number 19, and that's for the letters A to F. And then when you get from G to L, that's when they go into an independent mode. And you wanted to see where they're at with their writing of their words. And if you've been working on spelling, whether or not they include the right spelling. But mostly you're looking at, are they putting the place value together with those numbers? You get some very, very interesting things, just like we did with the counting up to and over 100. Very much so. Now, the great thing too is if you are working with someone who's struggling or someone who or a class that's are not up to 250,000, you can just white that out and put your own numbers in there. And L is kind of, I just say, okay, at the bottom, there's a real doozy at the bottom, just give it your best shot, because we know they're not really doing that until grade 6 and grade 7. But you will have kids that have figured out the place value system and will go through it. So that's a really good one. So if you go to the next slide.
I was just going to say about this one too. I have teachers asking, well, what about their spelling? Does the spelling need to be right? Well, what are we trying to look for in this task? We're looking for their concept of place value.
Exactly. So here's some examples of different things that you will get. The first one's the ABDE there that I took a portion of is showing like D. Obviously not understanding the whole cycle of the place value, and that if you get enough of those kids in your class, that means you need to go back and revisit that. And same with E, just the fact that they're having those 4 numbers. Now, we're not seeing commas, we're not to use commas, and we have a very open conversation about that. So hopefully there's the nice spaces in between there. For the other ones, some things you're looking for the middle one, J, K, and L, you're looking for that word and, because and should only be used if there's a decimal. So you have to watch your own speech, and I still do it because we hear it on the news and we hear it every time we talk about money. So we want 13,648. We don't want those ands there. And we want to be really explicit and tell them that's when you're using your decimal point and you're saying 13 and 4/10. So to eliminate that, and that takes some teaching as well and reminding. And I have my kids just point it out every time I make that mistake. And then the bottom one I thought was really interesting, and I would probably have a discussion with this child because they're saying 504 for the top one, but then when they get down to 6,003, they're writing 600. So I probably talked to them about using different numbers probably, but about why those are the same and which one do they think they need to change, and that will give you great information on what they're thinking when they're writing that, or if they've just had a moment and meant to write 1,000 and wrote hundreds. So sometimes you just got to dig a little deeper on these ones, but this is a great kind of data collection one to see where your class is at and where you need to spend some time. The biggest. Okay, so this one, See, I love all of these. I do all of these. Circle the biggest. It's not so much about them circling it. And I put those yellow arrows there because I really want to emphasize it's that how do you know it's bigger? How do you know it's larger? How many times larger is it? And you can, with any of these, you can make them your own. You can just start with how do you know it's larger or greater, whatever word that we're using right now. And you can white out the other one and not worry about how many times greater is it. Just it's your focus on what you want to make this assessment do for you. And you may only give the first one or the first two, or you might only give number 3 because you just want a quick, ticket out of the door. Where are you at with your understanding of the magnitude of decimals? So do take apart these assessments and choose the ones you want to do. And we're going to really see that in the next ones as well. It's just really target, like what are you looking for, and make it easy on yourself and make it something that jumps out at you and gives you a clear indication of where you need to go and how you need to move those students. This is a great game. It's a really great game, and it's a game that you can play with grade 2s all the way up. So the students have these and they cut them out, and they each make a number with the 3 zeros, the decimal point, and the 8, and then they compare each other's, and they have to tell the person how they would change the value of the number. So usually it's by what are you going to multiply or divide by? What multiple of 10? So that again gets that whole understanding that place value is multiples of 10 going, whether or not you're multiplying or dividing by 10. It works really well. It seems really, really simple, but the aha moments are very significant. And for those lower grades, or if you're working with someone who you need to differentiate, everybody else is working with decimals, but you've got, a few that aren't quite there yet, just remove the decimal point, and they can start just working with those whole numbers instead of the smaller units of 1. So that's one that again is in the First Steps, on the First Steps website that you can print out for yourself. Okay, these are all the decimal sets. And so we know we're starting decimals in grade 4. These again, cut them up if you want. If you just want to give A, just give them A. Maybe you've just done, a few lessons, hands-on lessons, and you just want to check where they're at. Again, that ticket out the door, checking their understanding very quickly. They go kind of in complexity from comparing them and all the way up to sequencing. And you see an F back to the counting session that we did. F is that counting using the decimal numbers and how important that is, especially those turnovers. E is a great discussion one. And again, that can be done as a collaborative activity. It doesn't have to be done as a diagnostic. And like we see in many times, some of the collaborative activities we do actually can become a really great diagnostic if you're looking for conversation as proof of understanding. And the next one, there's even more of them, I love these ones. So what do you think this number means? It's so open. And again, that can be a virtual, not a virtual, but a vertical whiteboard exercise. And just, what does that mean? What does it look like to you? Describe it in words, numbers, pictures, on a number line, any way you like. And then they made it concrete, they made it real world-ish by saying, okay, well, if someone asked you for 85.6, of course, that's not going to happen. But what would that look like? How many apples is that? Very interesting responses. That's, I think, why I love these so much, is because I've seen so many of the responses. And then this next one, the money one, is great, that they do 33 divided by 8. And I always do it in front of them so they believe that that's the number that comes out. Now they have to decide how much money to give them. And this works in with your financial literacy. But again, the important part is, well, how did you make that determination? And you can probably guess what people are going to say. but I think the most common is $5.25 is the answer if they don't understand, because they think they have 125 cents behind that decimal. And so they think, well, 125 cents, there's another dollar in there. So you watch for that $5.25. And I swear that before we really get into things, about a third of my class will put that. Others will draw or say $4.12, and then they'll draw like half a penny, which is quite funny. But again, that indicates to me their understanding. So another phenomenal one to give them.
Okay.
And I think that's it. Woo! It's always so fast. I always have so much to say. So again, we're just going back over this whole thing about understanding number as a representation of quantity, and how we need the counting skills, and how we need the subitizing skills, and that counting has a purpose, and then eventually it's going to make equivalent sets. Then it develops into part whole understanding, and that we can actually see groups within amounts so that we can add and subtract small amounts, eventually larger amounts. Noticing attributes of quantity, what's same, what's different, what's more, what's less, how much more, how much less, all of those types of activities. This is what's giving the foundation to your kids' number sense. Seeing numbers as a representation of quantity, just keep that in the back of your mind. This is what we're working for, them understanding the magnitude, the difference. Today I did the magnitude difference between 1,000th and a 1 whole. We did it with clay, we did it with paper, so they're understanding that those decimal points are a huge difference in the magnitude and the way they should be thinking. So hopefully that helped. Hopefully there's a lot there. There's a lot to unpack. So we will be sending this recording to everybody again, so that you can go back through it and see these different things. We'll also have a folder in a Google Drive that we will be giving you the link to, that will have either links or activities that will support the diagnostics that we showed you here today. But as always, if you have any questions, you can either stay. We don't mind staying late, of course, because we started late, or you can email us. So yes, please do so if you have any more questions or need some advice for different learning opportunities for your kids. Jen, do you want to have the last word?
No, just thank you everyone for your patience this afternoon, and thanks for joining us. And our next session is coming up, I think, in 2 weeks again.
Yes.
So watch for that email.
So how to go about introducing that additive and multiplicative thinking. Yeah. All right. Thank you so much. And we look forward to seeing you next time. And if you know anybody else that wants to join in, you can still register. Jen and I will probably keep going with these sessions. So it's a great opportunity to use your BCMT membership and get this free Pro-D that hopefully is quick and super useful for you, that you can use the very next day, which is always nice. Okay.
All right.
We'll just stay. If you have any questions, you can either put it in the chat or just share yourself and talk to us face to face. Got lots of thank yous, which is great. I love how people are all over the province. That's the best thing.
Amazing.
All the different places.
Some positive things out of COVID.
Yes, we're able to reach everybody.
Yeah.
Okay, well, there we go. We had Global Play Day today. So it was quite chaos. Well, it wasn't chaos. It was subdued chaos, as every kid made decisions on how they were going to spend the whole day and how they were going to play. And so a little frazzled, probably why the password didn't work today.
Jeez.
Okay, I'm just going to do the chat, and I think we're good to go.
Can I quickly ask a question?
Absolutely.
And it's not, I stalled because it's not really on the math thing. It's more on the Zoom presenting, because I'm part of a math fair that's coming up, and I've never presented by Zoom. And I appreciate that this went down for you. I know it wasn't great for you, but it was helpful to me, because that's what happens. And I'm just wondering if you can give any pointers of when you're presenting your math, the best way to do that. Should we stop the recording, or I don't know?
Oh yeah, we can stop the recording. That's a great idea. See, there's a pointer right there.